Good morning, guys. Today we're going to go over a review of factorization. These are the factorization methods you should know already, or you just learn them today, but you will need them. So pretty much common factor, difference of squares, quadratics, grouping, and decomposition. We're going to go over all of them and rewatch this video if you need to rewatch this video. Now to begin, one thing, common factor. You always try to do common factor first, always, for any polynomial equation you're given. If they ask you to factor, before you do anything else, no matter how many terms you're looking at, always common factor first. Then you look at the factors you're left with, and if you can factor any of those factors, again, you continue with the factorization process. Now let's begin. And I'll give you an example of a common factor that is factored again. For example, if I'm given 2x cubed minus 8x squared. Now we're going to do common factor first, and then we're going to do another type of factorization, so I'm going to explain two in one go. Now in common factor, you first focus on the number. Is there a number that can divide them both evenly? No decimals, no fractions. Is there a number that can divide both of these? And the answer would be yes. The number that is common would be 2. And you always choose the highest number. So if this were a 4, even though 2 could evenly divide both numbers, 4, that's why it's greatest common factor. You use the biggest number and biggest variable. You try to use the biggest that is common among all of them. So the biggest number that can, evenly divide these two is 2. After you focus on the number, then you focus on the letter. They both have x in common. Awesome. So we use the x of smallest degree or the letter of smallest degree that is common among all of them. So even though we pick the biggest number that can divide any, we actually have to pick the smallest degree. So the smallest degree would be 2x squared. Now you begin a process of division. Many students subtract. No, you have to divide. And you divide the original number by what's common. And whatever the answer is, you put inside the parentheses. So when I divide 2x cubed times 2x squared, and actually, just to make this a better example, let's change this to 2x4. Because I'd like to do something else with this one. Now, 2x4 and negative 8x squared, the number did not change, it's still 2, and the letter did not change, it's still x squared, second degree. Because again, we choose the biggest number that can divide everything, and the smallest degree of letter or variable that is among all terms, which would be x squared. Now, when I divide the original number by what's common, I'm left with only an x squared. And then when I divide this number, or this term, by this term, I'm left with negative 4. If you're unsure about your greatest common factor, and you want to confirm, you can just distribute. If you multiply this by this, do I get this? Yes. If I multiply this by this, do I get this? Yes. So it's correct. Common factor is like a reverse distributive. You're taking out what's common. In distributive, you're going to multiply a bunch of terms by a common term, term or factor. So common factor is like a reverse distributive. You're taking out whatever whatever everything has in common. Now, I said in the beginning, you always do common factor first. If it has common factor. Sometimes you don't have common factor, but you always have to try that first. Now, after I do common factor, you evaluate your answer again. In this case, I can factor this again using the difference of squares. Now let's explain difference of squares. In difference of squares, it's a particular pattern that you have to be able to visualize. For example, there has to be a minus sign always, a subtraction. That's why it's called difference, not sum of squares. Difference of squares. And both numbers have to be perfect squares. So again, this one can be square, this one has a perfect root, this one has a perfect root, x and 2. Other patterns are, for example, x to the 4 minus 25. The square root of this would be x squared. The square root of this would be 5, and then there's a minus between them. So always, if you see two terms, see if there's a difference of squares, because that's usually after you common factor the only thing you can do with two terms, a difference of squares. So when we do have a difference of squares, you actually break it down into two other factors. And what you do is you take the square of the first one, the square root of the first one, which would be x, and you place it here. You take the square root of the second one, which would be 2, and then you always put plus minus. Order doesn't matter because it's a multiplication. You just put plus minus, and then we have to add whatever was our, what our common factor was. And that's pretty much difference of squares. I'm going to do a couple of other examples. So here I did a common factor and a difference of squares. If I were to multiply these three, I would end up with this term. If you don't believe me, you can just try it out. Now, why do you need to factor? Simple. Because this tells you where the zeros are, the solutions. I know 0. Okay, looking at this polynomial, I can easily say 0 is a solution because my x is included in both terms. But then after that, it's kind of difficult. But once you factor, I know 0 is a solution. I know -2 and +2 are also solutions. So factorization is incredibly important to be able to, later on as you'll see this year, be able to remove factors. So again, make sure you know how to factor, because in the next class, we'll be doing a ton of factoring in order to find the answer. So again, this year, the answer won't be factoring. So you need to factor to then be able to determine the proper answer with another process. So if you don't know factoring, it's going to be a problem. Let's do a couple of other common factors and a couple of other differences of squares. You could have a case in which only a letter is what's in common, and that's fine. The numbers, there is no number besides 1. You can evenly divide these two. So the numbers stay the same, but the letters would be x squared. Here I'd be left with a 3. Here I'd be left with a 2x squared. Note it's not in standard form, but it doesn't really matter. Let's do another common factor in which I only have a number in common. 5x squared minus plus 25y cubed. Profe, the letters are different. Doesn't matter. They're not in common. So 5, then inside I would have x squared plus 5y cubed. If I were to multiply this, I would end up with the original polynomial. Also, they might not have anything in common. 3x squared minus 7z2. No common factor. So that's pretty straightforward. Now let's focus on difference of squares. Again, for example, 100 minus x squared. This would be 10 plus x, 10 minus x. If you multiply these two, you will end up with this. Perfect square, break it down. That's pretty much it. Let's do another example. So this is one of the patterns you have to immediately recognize and be able to do quickly. For example, also, if you want to force a difference of squares, let's say, for example, they give you this crazy number. Even though I don't expect you to see this like this, but it might happen in the SATs or something. If you're given this, for example, expression, they're asking you to, just difference of squares or something, you should know that this would become the square of the first, the square root of the first. I always say square. The square root of the first and the square root of the second plus minus. So this, if you use the square root, you can make anything that has a minus, a difference of squares. But the point of difference of squares is to be able to recognize perfect squares and easily break them up so you can work on them and find the solutions in an easy manner. So again, that takes care of common factor and difference of squares.